Okay, so we are entering our last unit, which is systems of equations. And systems of equations is going to require us to graph again. So we want to come back and kind of refresh our memory, remind us of graphing in regards to equations. So again, we need to remember what the standard form equation is. And the standard form equation is ax plus by is equal to c. And again, a is a coefficient of number, b is a number, and c is a number. That's called standard form equation, and pretty tough to graph from a standard form equation. So we're always able to take a standard form equation and convert it into a slope-intercept equation. And our slope-intercept equation is y equals mx plus b, where m is our slope, and b is the y-intercept. And that's the point where the line crosses the y-axis, which is your vertical. So as I look at these three equations, 7x minus 3y equals 15, 4x plus 16y equals 32, and 35x plus 7y equals 49, I notice that these are standard form equations. So in order to graph them, it's easier to convert them into slope-intercept. So if you're ever asked to graph, you can always convert it into slope-intercept. So we need to get the y by itself, equal sign, the x, and the b. So I'm going to subtract 7x from both sides. You get a negative 3y is equal to, and then negative 7x and 15 are not like terms. So we're going to go with negative 7x plus 15. And now we need to get a single y. So we're going to divide by negative 3, divide by negative 3, divide by negative 3. These cancel out, and you get y is equal to a negative 7 divided by negative 3. They don't go into it evenly, so I'm just going to go 7 thirds x. Sorry, I'm running onto that line. And then in positive 15 divided by negative 3 would be minus 5. So I'm going to take a highlighter so you can see that a little bit better. Y equals negative 7 over 3x minus 5. For the next one, I'll do the exact same thing, and I'll let you do the last one. If you want to pause the computer right now and try this on your own, go for it. So you're going to subtract 4x from both sides, and you get 16y is equal to negative 4x plus 32. Then we need to get a single coefficient for y, so we always divide by whatever the coefficient is. These cancel, and you get y is equal to negative 4 over positive 16 would be a negative, and it would reduce 1 over 4x, negative 1/4 x. Plus, and then 32 divided by 16 is 2. Okay? Why don't you pause the computer and do number 3. Okay, since you paused the computer, I'm going to come back and I'm just going to give you the answer. I believe the answer is y is equal to a negative 5x plus 7. Okay, now we're going to graph, and I'm going to graph a couple of these for you. Number 1 is already in slope-intercept form. So we identify our slope, our m, is a positive 2 or 2 over 1. We identify our b, which is the y-intercept, as negative 3. Come down to the graph, and you negative 3 on the y-axis, 1, 2, 3. And you go up 2 to the right one, up 2 to the right one, up 2 to the right one. And we plot our line. You could put as many points as you want. When we're doing systems, I recommend that you put every point. For the next one, the slope, our m is 1 over 4. Our b is 2. It could also be called an SP, a starting point. So SP, starting point, b, they mean the same thing. So our starting point is 2 on the y-axis because we know it's slope-intercept form. And then our slope is 1 over 4, rise over run. So rise 1, run 4. Up 1 to the right 4. Also, if you can't go up 1 to the right 4, or you can also go down 1 to the left 4. Those are the 3 points that we put on the line. Those points are also known as solutions. So every single time you have a point that is on a line, it's called a solution. Okay, our third one, x equals 1. Well, our slope in this case is undefined because it's a vux, if we remember that. Vux. Vertical line, undefined slope, x equals a value. And our b, it's not a b, it's an x-intercept. And the x-intercept is equal to 1, 0. So we go to 1 on our x-intercept, and then every other point where x equals 1 is a solution. So we draw our vertical line just like that. Okay. The last few that we're going to do come down here, and I notice that these equations do not look like these equations, right? They're different. So this one is a standard form. And you could graph from the x and y intercepts, or we could solve for y. So I'm going to solve for y. Subtract an x, and you get 3y is equal to a negative x plus 9. Divide by 3. And you get y is equal to a negative 1/3 x plus 3. Okay, so there is my equation, y equals negative 1/3 x plus 3. My slope, negative 1/3. My b, positive 3. So 1, 2, 3 up on the y-axis, down 1 to the right 3. If you have a negative, you always have to go down 1 and to the right, or up 1 and to the left. And then we graph our line. The next one, 3x minus 6y, also standard form. So I'm going to convert that into slope-intercept, by the way we've been doing it. If you want to pause your computer and try this before I do it, go for it. Minus 3x, minus 3x. You get negative 6y is equal to a negative 3x plus 12. Divide by negative 6. These cancel out. You get y is equal to a negative 3 over negative 6 would actually be a negative over a negative turns into a positive. So positive 3 over positive 6. And then you reduce that to a positive 1/2. And then positive 12 divided by negative 6 would be minus 2. So we go down to negative 2. That's our y-intercept, right? Our slope is 1/2. Our y-intercept is negative 2. So down to negative 2, and then up 1 to the right 2. We could go again 1 to the right 2, and then we could go down 1 to the left 2, down 1 to the left 2, and then you have your line. And then the last one is y equals negative 2. So our slope and our y-intercept. This HOI, a y equals is a HOI. So horizontal line, 0 slope, 0. And our b is negative 2. So our y-intercept, negative 2 on the y-axis. And then it is a horizontal line with that HOI. I hope this was a quick refresher for you on how to graph standard form as well as slope-intercept lines. Now start practicing on the worksheet that has been provided.